Sarah. I'll try to do my best. I don't have a lot of time today to be able to do these, but I'll just start off doing a few of them, and then I have to probably go because I have to create some lesson plans for today. What I'll do is I'll do this first question. Here's your function, and we want to simplify it using this evaluation. So our function is this quadratic equation, and you want to evaluate for f of x plus h minus f of x over h. So when you evaluate, you're taking this x plus h and substituting it into here and there. And then this is saying subtract the original function and then divide by h. So let's go ahead and begin. So negative, and I'm going to replace that x with x plus h, and then squared. Minus 2, and then replace the x with x plus h, and then plus 3. So there's the first piece of this. Now I'm just going to change colors. Now minus, this is still the numerator, I just kind of run out of room here, minus the function. So the function is minus, and then minus x squared minus 2x plus 3. So I just took care of now that piece. And then all over this h. Right, you do have a lot of cleanup to do to simplify this problem. So I'm just going to scoot over to here. We want to do the green piece. So we have minus, and then x plus h, and x plus h. We're going to FOIL that later. And then we have minus 2, x plus h, and then plus 3. And then it's minusing this red piece. And then it's all over that h. So here's what it looks like all together. So we're going to FOIL this green. So first, outside, inside, last. So first, so we get x squared outside, x times h is xh, inside, h times x is xh again, and then h times h is h squared. Then we're going to distribute this negative 2 through. So we get negative 2x, negative 2h, and then we have that plus 3 in that bracket. Now with this red, I'm going to distribute the negative through. So we get a positive x squared, a positive 2x, and then a negative 3. And then all over that same h. Now I'm going to clean up the green some more. So I'm going to distribute this negative through. These combine to 2xh. Now we distribute the negative through to all the terms. So we get negative x squared, negative 2xh, and then negative h squared. And then we still have over here the negative 2x, the negative 2h, and then the plus 3. And then in the red, we have x squared plus 2x minus 3. All over h. Now let's see what things can cancel. This negative x squared and this x squared cancels. Negative 2x and plus 2x cancels. 3 and negative 3 cancels. And now what you're left with in the numerator is negative 2xh minus h squared minus 2h all over that same black h. Now take out the greatest common factor out of that numerator. So we have an h, and we're left with negative 2x, negative h, negative 2, all over h. And then what you can do is you can cancel this common factor. And then your final answer is what's in that parentheses, minus 2x minus h minus 2. All right, I'm going to go ahead and grab the next one. So it says find the domain of that function. So the domain of function is what can you plug in for x? Well, there's a restriction in this piece right here. It cannot be undefined. Undefined means something over 0. This is a big problem. So if I set that function equal to 0 and solve it for x, that's where the domain restrictions will be. So when I first push everything over to the other side, so it makes that leading coefficient positive. So now I have a positive x squared, a positive 2x, and then a minus 3. Now I factor it. I'm assuming your teacher probably taught you factoring. So you say, what are the factors of negative 3 that add to 2? Well, you get a positive 3 and a negative 1. When you FOIL that back out, you'll be left with this trinomial. Now you set each of those factors equal to 0 and solve for x. So you're going to get negative 3 here and a positive 1. So the domain is everything but these two numbers. So you'd say all reals, that's a shortcut for reals, except x can't be negative 3 and x can't be 1. Those are the two restrictions on the domain, two things you can't plug in. What they'll end up becoming later on are what we call vertical asymptotes. I can probably do one more here, and then I have to go. I'm sorry. So this inequality is saying when is the function greater than or equal to 0? So negative x squared minus 2x plus 3 greater than or equal to 0. So you may want to try and factor it again. So if I factor this, you may want to push everything over the other side. So you get a negative 1 out, plus 2x minus 3, and then greater than or equal to 0. And then you would factor it like we were doing before. And you say, what are the factors of 3 that add to 2? And then you would set each piece equal to 0, greater than or equal to 0. Actually, we probably need to divide this first by negative 1 to get rid of this. So divide by negative 1, divide by negative 1. And what happens is this sign is going to switch directions. So now we're left with x plus 3, x minus 1, and then flip this, and then 0 divided by negative 1 is still 0. Now we solve them individually for x. So x plus 3 less than or equal to 0, and x minus 1 less than or equal to 0. And then you solve them, so you subtract 3, and then you add 1 to both sides. And you may want to check your solutions here to verify that they are truly, in fact, true to the inequality. Sorry, I have to go, but here's the recording for you.